There are, I think, two types of CO2 emissions in the world today. The ones that are related to using mechanical power, an engine, or for heating purposes or whatever, and those are relatively easy to eliminate. You change to a different type of drivetrain or a different type of heating system or whatever. But then you have industrial processes where CO2 emissions are an intrinsic part of the business you do. That goes for the steel industry, that goes for the cement industry, for example. And that means that in order to get rid of CO2 emissions, we need to change the way we make steel. It has been the same since the blast furnace was invented in 1300 something, and now we need to move away from that. So we are in the middle of a huge technology shift here. We're one of the so-called hard-to-abate sectors.
I was reading about hybrid technology and some of the breakthroughs that you're driving there. Could you tell us a little bit more about what that is?
We announced this as an initiative in 2016, in April, together with two partners, I should say, Vattenfall, our electricity provider, and LKAB, our iron ore supplier. And we ran a feasibility study for 2 years or so, and we became more convinced that this is exactly the right way to go. So we decided to build a pilot plant, which is now up and running, a research facility where we learn how to run this process in an industrial environment. And we've also made the decision to build a full-scale plant that will go into production in 2026, which is then what is enabling us to make this commitment of supplying fossil-free steel to our customers as a commercial product in 2026. On the left-hand side, we're trying to illustrate the traditional blast furnace method, which generates a lot of CO2 emissions. And that's not because we're sloppy in the industry, but because the raw material that we're using, iron ore, is pretty much iron oxide. It's iron and it's oxygen. And in order to get to the iron, you need to remove the oxygen. And since the blast furnace was invented in 1300 something, that has been done with carbon in the form of coke. And what happens then is that the oxygen in iron ore moves to carbon and forms CO2, and you're left with the iron, which is what you want. But this also means that for every ton of iron that you make with this technology, you generate at least 1.5 tons of CO2. That's part of the deal. That's a chemical fact. You can't really do much about it. So we need to do something in a different way. And what the right-hand side here tries to illustrate is that what we want to do in the future is to use clean electricity, generate hydrogen gas, green hydrogen from water with electrolysis, and then we're going to use hydrogen to get the oxygen out of the iron ore. And what happens then is that the oxygen in the iron ore moves not to carbon and forms CO2, but to hydrogen and forms H2O, also known as water, as a byproduct. And that is our way of eliminating the CO2 emissions in the steel industry going forward.